Hi, I'm Whitney Espick, the CEO of the MIT Alumni Association, and I hope you enjoy this digital production created for alumni and friends like you.
Hi everyone, my name is Will Knight. I am a senior editor at MIT Technology Review, and I'm here to do the Q&A. It's a real honor to be on the stage with you both. I don't need the glasses to know who you are. And also with this illustrious audience, and I have to say thank you to you guys because you're going to make me seem very smart by feeding me all my questions. And we're going to go through the ones that have been submitted through the app and according to the ones that were most popular. Now, the first one we have is one for Professor Sharp. It's about the detection of cancer, and someone's asking, is there a point at which we are detecting cancer too much almost? So I would, if it's okay, like to pass it into one. Do you think that the huge revolution is coming in how we detect cancer thanks to AI, first of all, and then other risks?
I think we will have remarkable advances in detecting cancer. The question is premised on the issue, let's say breast or prostate, where we treat 10 people to potentially advance the health of one. Mm-hmm. And the same science that allows us to distinguish different types of cancer will allow us, this is using machine learning and all the information I was talking about, will allow us to distinguish which cancers need to be treated and which do not. Mm-hmm. And it goes hand in glove. So I think the only way we're going to be able to advance the quality of cancer care and treatment is using more information to distinguish individuals who have certain diseases at certain sites and then treat those cases.
Right. And you mentioned David Sontag and Regina Barzilay, two amazing faculty here.
Amazing faculty in electrical engineering and computer science, and are bringing that technology and more importantly, a deep interest in this whole problem and helping us make the bridge from being an old molecular biologist to actually talking this new language and thinking about how it could potentially change our science.
Yeah, so actually just while we're on that note, Pattie, I wonder if you're interested in the genomic AI revolution and that helping inform the kind of work you do.
I'm not using that type of data in my work, but I think there's a parallel here in that there is a real potential for personalizing healthcare more and using all this data that we have about people, whether it is their genome, whether it is their behavioral data, and more, that can all be used to personalize how we help people the treatment, and also to be much more preventative and sort of intervene at earlier stages.
You can imagine if you had a genetic predisposition that you needed certain foods to smell particularly bad, maybe that'd be useful. So one question which has shot up in popularity I'm not surprised about, it's not directly relevant to your work, but we should respect that everybody's very interested in this topic, is if machines are going to replace humans, what will humans do? And I wonder, you're both taking an interest in artificial intelligence, and this is something that I know the Institute is very, very thoughtful about, and it is sort of a big pressing question. Do you think AI is going to be leading to mass change in employment, and how do you think about that?
Yeah.
You take the first, I'll take the second.
Yeah. I'm not that worried that machines will take over our jobs. Right. I think that the vision of machines being used increasingly in this decision-making in all the aspects of work, so the machine and the human collaborating, basically, to be able to perform at a higher level. That's a more realistic vision than that of machines completely autonomous, putting us out of a job.
Well, I know there's the case of, sorry, please.
So I'll just give you an example. I grew up in Kentucky, and I worked on a farm until I was 18. None of my, colleagues of the same age work on a farm. We went from, 30-40% of people involved in agriculture to 2%. And we're feeding everybody. And we freed those individuals to do things like come to MIT and do some significant work.
With Nobel Prizes.
I'm sure not all of them have done it, but we freed some. And I think we will find that when these machines take on jobs that we really would prefer not to do, we will find ways of gainfully using our work to change the world in much more exciting ways.
Right. Well,
So it's just, what's the big deal? Let's just go do it.
in the case of the work going on at MGH on breast cancer that Regina Basile is doing, I know there was a worry, we're going to suddenly put radiologists out of work. But of course, there's so much that doctors and medical experts do that is not automatable at all. It's important to have to keep some sense of perspective.
This will be an augmentation for them.
Right.
They will be able to see things and then make decisions that they currently can't do because they can't just bring that much information to the point of making that decision.
Right.
And they will with this technology, and that'll make them much more effective and the patients better, and that enriches their life and the patient's life.
Right. Okay, well, so a question for you, Pattie. Several people in the audience have endorsed the question of has facial recognition been used as part of a wearable to help Alzheimer's patients? And maybe you could sort of expand on that kind of idea.
It has been used in research settings. There was actually a lot of interest in memory augmentation about 20 years ago when the Media Lab had sort of a first wave of wearable computers, and a lot of the applications that we were looking at were memory augmentation based. There's also been work at Intel. Gordon Bell has been very interested in this topic at Microsoft in England, a research lab. But it hasn't sufficiently I think there's a new opportunity really to look into this topic, because 20 years later, we can do face recognition on smartphones, things like that weren't possible 20 years ago. We didn't even have smartphones back then. The wearable computers that we worked with were like laptops in our backpacks. So I think there's a real opportunity to revisit that type of work again, and that the time is right now to create prototypes for products that could do these types of things.
And someone was asking about autism, and I imagine the same is true for that. We have another question here, which I think is a fantastic one. And someone is asking about the importance of users and, I guess, engineers understanding their systems. And this sort of draws us to the challenges of working maybe with machine learning when it's incredibly complicated and a bit opaque. So maybe, Professor Sharp, are you thinking about I'm sure you are, but the kind of challenges of working with this sort of new paradigm of machine learning?
Science has grown and engineering has grown to the point that no single individual can be an expert in everything.
Right.
And what you have to do is learn enough of the language that you can communicate with the expert, and you can develop confidence in experts who are, critical and leaders in their field, and then work together. And that's why this community in Cambridge has developed, because the science is moving so fast, the computation, the machine learning, all of this is moving so fast that if you have a critical mass of expertise in various areas, you are at a tremendous advantage.
Right.
And this is, just a snowball running downhill. It's going to get bigger and bigger and bigger, because of the rate of change.
I would like to add, though, that I think for the first time in humanity, machines are discovering new knowledge, and they represent it in ways that they cannot necessarily communicate well to people. So there is, I think, a very important issue in which a lot of faculty here at MIT work on, that we have to develop neural network systems that can explain their reasoning so that we can understand the knowledge that they develop from looking at lots of data. And,
and I know there are a number of research groups at MIT that are working very hard on the question of sort of finding new ways to interact with these more opaque machine learning systems. So we have time just for one question, and I'm going to sort of garble slightly one that came in asking about whether some of the stuff that you're working on, Professor Sharp in particular, could limit healthcare coverage. But I'm just wondering if we could expand and say, how is genomics and AI going to change healthcare more generally? How is it going to change the everyday lives of patients?
Well, I hope, and this is a hope because it really is, got to be a systems issue, and that's part of what we have to do over the next decade, that by using more information and being able to distinguish patients earlier, treat them better, we will have a decrease in cost or a constant cost, but an increased quality. I don't think we can go to an increased quality of life through healthcare unless we make this transformation.
Right.
I just think it's the biggest opportunity in front of us, and we've just got to make this transformation.
That's a great answer. Do you want to add any thoughts?
Just, yeah, I totally agree. And the ability to be more, to intervene earlier on and do more preventative interventions is incredibly exciting, I think.
Great. Well, I think we're very lucky to have people such as yourselves thinking about this and working on this and leading that charge. So we're going to take a break now, but please give a big round of applause to our speakers. Thank you, guys. Thank you so much. That was wonderful.
Thanks for joining us. And for more information on how to connect with the MIT Alumni Association, please visit our website.